We can subtract mixed numbers using the two methods that we use to add them, either converting each one to improper fractions and subtracting, or subtracting the like parts. Let's start by converting each of these to improper fractions and subtracting those. So if we have 5 2/3, that would be 5 wholes cut into 3 parts each, so that would be 15 parts, plus the 2 more we have already, so we would have 17 of the parts, 17/3. 2 8/9, we have 2 wholes, each hole cut into 9 pieces, so that would give us a total of 18 pieces, plus the 8 we already have, so we would have 26 ninths. Now, to subtract, just like with addition, it's very easy to do if we have common denominators. So we need to convert these into equivalent fractions with common denominators. Of course, 9 would be a common denominator. There are many of them, so let's just use 9. If we use 9, this first fraction, we must have multiplied the denominator by 3. So the fundamental law of fraction says we would need to do the same thing to the numerator. So we have 17 times 3, which would be 51 ninths. Subtract, we already have the common denominator, 26 ninths, so we can leave it as 26. So we have 25 ninths. Again, this fraction is simplified because the greatest common factor of the numerator and denominator, 25 and 9, would be 1. So the greatest common factor is 1. It is, however, of course, improper, so we need to properify it. We do that by dividing. 25 divided by 9. See how many wholes are in there. 9 would go into 25, 2, with remaining 7 pieces. Those pieces then are ninths. So our final answer would be 2 7 ninths. Now let's take the same problem, 5 2/3 minus 2 8/9. And let's subtract like parts. Again, like addition, it's easier to do this if we have them lined up vertically. So let's go ahead and line these up vertically. Again, we still need common denominators for the fractional parts. So again, we will choose ninths. And again, this denominator was multiplied by 3, so its numerator also must be multiplied by 3. So that gives us 6 ninths. So we have 5 6 ninths, and we're going to subtract 2 8 ninths. With addition, we could just add the like parts and take care of properifying at the end. But subtraction, because sometimes we don't have enough to subtract, we really need to approach it right to left, just like our subtraction algorithm. And we notice we're taking 6 ninths minus 8 ninths, and we don't have enough. But in mathematics, we can rewrite. So we could trade in, remember it's not borrowing, 1 whole from the 5, leaving us 4. Remember, 1 whole can be written as 9 ninths. So just showing our work up here, that would give us then 15 ninths. Then we have enough ninths, we can subtract the 8 ninths, and that would give us the 7 ninths. Then we can subtract the whole unit parts. 4 subtract 2, we would have 2. So again, we have 2 7 ninths.